because strings are not as heavy topic as we just talked about, but I think strings are extremely important to JavaScript. JavaScript and strings are extremely friendly to each other. The reason for this is the strings are everywhere. HTML is a string, JavaScript is a string, your classes are strings. Every object in JavaScript has the toString method that casts the object to a string, stringified, and every time you talk about Ajax or talking to the server or consuming services or JSON or XML, everything of those is strings. You want to consume a service, you're actually sending a string, JSON string. You receive data from a server, it's usually a string. So strings play a key role in JavaScript. As you know, strings are sequences of characters. They could be either in single quote or double quote. We've seen that. It doesn't matter how you use it. You cannot combine them in one string, but you can build one string like this and the other like that. That will be okay. It's not a problem. Strings are passed by value, as we've seen. They are primitive types, and they are immutable. Every time you make a change to a string, there is a new string created from scratch. So that makes strings not very performant and hard to maintain. So if you have a piece of code in JavaScript that starts manipulating strings a lot, that could be quite a performance bottleneck. String wrapper, they are primitive types, but as we've seen, primitive types can also have object constructors. So here's an example. Take a string and we assign it to a hard-coded value sample. This is a hard-coded string. So this is a primitive type, but it still has access to some of the properties that string provides, like length. That gives you how many characters the string has. However, what you can do is create a new object by calling the string constructor and giving it a string. This will give pretty much the same effect, but what you get here is an object with the value of the string that you've sent. So again, this is pretty similar in behavior, but there's a subtle difference in the way that JavaScript treats those two objects. Well, we have a debugger session, which will not run unless we open the DevTools. Okay, so here we are in the debugger, and we can see that we have two objects, two variables. One of them is a string, which is assigned to a value, and the other creates a string object, where you can see that it's slightly different in implementation, in what it provides. It looks like an array more, but even though they both allow the same interaction. So if we take here str at place 4, we'll get the character, and if we get str obj at place 4, we'll still get the same, and length will work the same. And so on and so forth. So we can access the same properties, and according to, in terms of functionality, we're actually dealing with the same implementation, just through different endpoints, let's say. So you can you can go from a string object to a primitive string type if you call the string constructor just like we saw, or you can call the string function without calling the constructor with new, and you'll get back into primitive string implementation. A few common string methods that are built into the language that you can use. Methods and properties. For example, length that we just saw, that returns the number of characters in the string. Indexing the string, so you can access a certain character in the string by its index number, just like we saw just now. Also, you can, if you have the index, you can get the character at this index by calling the string.character at and giving the index. Pretty similar to what the indexer does, just different notation. Then we have concatenation. I'll show you a small demo of concatenation and how it affects performance. There are a few ways to go over this and get more performance concatenation, because every time you concat two strings, you can do it with a plus sign, or you can call concat. You're actually creating a new string from the two strings that you've sent to it. You can replace a certain string with another string. So you can take a string and change characters or change pieces of it with replace. There is also an option to do things with regular expressions. I'll show you a quick demo of regular expressions as well. Or you can search if a certain string exists in one string and get you can search a regular expression in a string and see if one string exists in the other one. Index of. So index of and last index of will take a string and a substring and will tell you where the string exists in the other string, either from the left or from the right. So index of starts from the beginning of the string, and last index of starts from the end of the string, but they both find you the position of the string that you are looking for. And there's an optional parameter called position that if you provide, it will start from there. So you can actually scan a string to find all the occurrences of another substring if you keep looping the position. Right? You can split a string into an array by giving a separator, just a delimiter. You can trim all white spaces in a string from beginning and end by calling trim, or you can just trim right and trim left, and trim right and trim left with calling trim right and trim left. And we're going through because these are very simple, well-explained functions, but it's good to know about them. Then comes substr and substring, which are always confusing because they almost sound the same, but they're not exactly the same. So substr, I never remember which is which, by the way. So if I need to do a substring, I always go to W3C schools and I go and check which is which. But you are smart and you'll have a recording of it, and mark me saying string substr returns a substring from the start of the string, which is the first argument, to the length. So if I have a string, I take from where you want to start your substring and how long do you want it to be. On contrary, substring function actually takes the start and finish index. So you want to start here and finish here. So either you say start at character number 2 and take 30 characters from there, or you say start at character number 2 and stop at character number 32. It will give the same effect, but each of these functions, I don't know why you need both of them, but apparently somebody thought it would be a good idea and not confusing at all. They were wrong. And value of returns the primitive type of the string object. So you can construct a string like I showed you with a new keyword and create a new object of the string object. But if you have a string object, you can call string.valueof and you will get back to the string primitive or implementation. Quickly. Okay, I guess what we see is just what it says. So here is a string, sample string declared here. We're writing it out here. We're getting some properties like the length. We're getting a character at number 4, which means actually the 5th character in the string because we're at the 0 base. Same will be happening at character at the same place. So we'll return the character in this position. Then we can search whether there's an index of this string. Starting from the beginning of the string, we can search the index where this thing appears, or we can search. It's very confusing that it's also the string that we're looking for is string, and it's too much. If anybody says the word string right now, I'm going home. So here we are searching for the index from the beginning of the string. Here we're searching from the 8th character, and here we're searching for the 23rd character because it's very different. These 3 examples are, very different. But they can show you because if you really remember, the original string, you will see that the word string appears in different places in it. So you can search at different locations, starting at different locations. And then we have the difference between substr and substring. Don't ask me which is which, because I already don't remember. But one of them starts in at place number 3 and ends at place number 5, and the other one starts at place number 3 and takes 5 characters. I think it's the opposite too. But I don't care. They made it confusing, so they should take the consequences. So that's the result. Character at number 4 is L, and here it's again the same. Then we're finding the index. The first index is at number 7. Then if we start at character number 8, which means we shouldn't be finding it, we find the next index, which is number 22. So we're searching the word string inside here. This is the 8th character, and then we find it at number 3. And then when we search again from number 23, we get -1, which means this index of didn't find anything. And then we find a substring, take from number 3, and take 5 characters, so that's what we get. Or from number 3 and finish at 5, and that's what we get. Great. Concatenation, yeah, I mentioned this. Concatenation you can do with a few options. First, you have the plus, which we've seen in different cases. So you take 2 strings and concatenate them with plus. We can use the concat function. Like I mentioned, these have different performance impacts with different browsers. And you should take into account, if you're doing something which is heavy manipulation of strings, especially concatenation, this can be quite a heavy operation because strings are mutable, and every time you're going to recreate the same, because string operations are very difficult to optimize. They're difficult because they are texts, and you have to handle the text character by character anyway. There's no other way around it, but there are some optimizations in certain implementations of string functions. There is basically, you could do something like this. You can take an empty array, push all the strings into it, and then join them with an empty string. That will take all the strings, put them together, and then put them back out. In modern browsers, sometimes this is slower, but you have to really consider which of the options works best for you. Well, I don't remember if there was an original demo, but I created my own demo here. Okay. So I have a string here called lorem ipsum. I told you about lorem ipsum, right? You know what lorem ipsum is. It's a string. It's a text that you put in all kinds of sites if you just want to put bullshit text and you don't know. If you just want to see the layout of the site or the page or the print or the whatever, you put lorem ipsum, which is supposed to be some gibberish text, but it's not. It's actually based on Latin, and it talks about the pleasure and the pain. It's true. And there are many variants of lorem ipsum. There's bacon ipsum, and there is gangsta ipsum, and other implementations of ipsum. So it always starts with lorem ipsum. So this is my string, and I'm trying to concatenate it in different ways. Let's say, how many? 10 million times. Every time I push a button, I'm doing the operation here as the number here would suggest, and I have different implementation. Once with a plus, so I take the 2 strings and I do them with a plus. Otherwise, I do with concat, and the other way I try with an array join. Let's see. So when I use plus to do this, we get 490 milliseconds. If I use concat, it's much faster. And if I use array join, it's slow. And I can try to do this again. You can see the numbers. They are around the same consistency pretty much. I mean, one of them is around 200, 300, 400 milliseconds. The other is around 100 and something, and the other one is somewhere in the middle. I mean, they change every time, but the number. Yeah, maybe there is some caching, some in-memory caching in this case. Let's try this one more time. these are pretty consistent. Concatenation also. Yeah, and then, so take this into account, just saying. Escaping is also one more thing that you need to remember about strings. Strings can be bad. For example, here's an example of some very bad code that takes you to a very bad site. MSN is, don't want to go there. And the problem is that this could be an opening for injection with all kinds of hackers that can inject stuff into your. If you have some string manipulation in your HTML page, and you're just, let's say, taking a string and pushing it to the HTML page, it could be that your string contains a script inside it, and if you don't escape it correctly, escaping takes bad characters like these triangular brackets and makes them HTML safe. If you don't make them HTML safe, you could, with your JavaScript code, have injection of bad stuff into your page, and that's not good. So there are ways to do escaping. I think I have also a demo of different types of this, but that's one way to do it manually, to find and replace different occurrences. For example, find the greater than. This is taking regular expression. So here it takes the end and makes it an amp, which gets a safely HTML'd into an ampersand sign. Or if your string contains this triangular bracket, we're again putting it into an HTML safe less than. So we take a string and we escape it. We're changing all these bad characters into safe characters. Yeah, I created a demo for this. Okay, there are certain ways that this can be done. There is the escape and well, there is escaping and unescaping in HTML encoding. Why can't I? What's happening? I cannot click. Oh. Something is happening to my page. Better. So if I take a string like this and I escape it, escaping is done with the escape. This is a deprecated method. So if this one contains these unsafe characters, let's see what's the result if we call escape. Okay, nothing. Is this something happening? What? Okay, this worked, but I'm not sure why it's not working right now. Maybe because of this. Okay, so this is an example of an escaped string. This is not HTML. This is not HTML safe as escaping. This is a URL escaping. So this removes those bad characters from the URL, which is also something important you might want to do, because injection of bad code through strings can also occur from your, for example, query string. And so query string has to be also HTML safe. You can use escape and unescape to take and encode your URL correctly like this. If I take this string and unescape it back, we'll get the right string representation. So that's one. Maybe not delete. What the hell? Okay, we have the encode URI and decode URI, which should give us pretty much the same effect. I think those are also deprecated, and the effect is pretty much the same as what we've seen before. And here what we have is the HTML escaper, which is built into jQuery. So instead of doing what I showed you in the slide, so you have to actually implement yourself, you can use jQuery to escape a string like this. So this will contain some bad code that you don't want injected into your page. And if I run this now, it's alerting it. So you can see that those are actually characters that have been escaped into HTML safe characters. Okay. And yeah, that's also something which is valuable. I'm not sure it has any references in the slides, but it's also good to know since we're talking about strings, and like I mentioned, strings are tightly coupled with JSON and AJAX. Oh, come on. Okay. So you can take an object of a string like this, which let's say it's an object you receive from a service call, and you can convert it into a parsed object. So once I do this, what I have at hand is an object, and I can also go to properties of this object. So there is a way to take a string of an object and parse it into an actual JavaScript object, and vice versa. You can stringify using this stringify function. So if I take an object like this, here is the converted to an actual object, and I can access properties inside this object, even though it's been accepted as a string. And too many comment signs here. I hope I'm not. Okay. The other way around is to take an object like this, which is an actual object, and call json.stringify, and what I get in return is a string of this object. So if you need to send a string of an object as a string, you can do stringify, and if you receive a string, you can re-objectify it with JSON parse object. Just a few more things to know about strings. There's a live demo. Okay, these demos I think are less valuable than the ones that, oh, no, I'm not going to JsFiddle, okay, because I showed you a better demo. Okay, this is what we talked about, why strings could be bad for you. Here is a string that contains an HTML document redirect. This will redirect it to an unwanted site. And when we open this page, it will do a document write. This means it will take this script, even though it's a string, and make it into our HTML document. So whenever I open this one, it opens the page, the JavaScript runs, and we get redirected. So that's bad, because the user is maybe not aware of it. Okay, extensions of trim. Yeah, we talked about trimming right and trimming left, but I think we'll skip these demos because our time is short, and I think we've seen more valuable stuff. One last thing before the thank you slide is, trust me, it's the last. I just want to show that you can use regular expressions directly with JavaScript. There is a regexp class that you can instantiate. So you can create patterns. Here is, for example, some HTML snippet that has some tags with style. And suppose that I want to extract those styles. So I can create a regular expression that will take style, will take the double or single quote, then everything which is not double or single quote, and that means that everything inside here will be collected. And I'm putting here, I'm not going to get into regular expressions right now because I know it's very it's not the right time to do this. But if you're really interested in regular expressions, and you should be because you're smart people, maybe you can learn a little more. But I can tell you it's much easier to write a regular expression than to read it. So what I'm trying to do here is to extract those styles from the HTML element string. What I can do is create a pattern and then use it in a regular expression, and then I can find the match strings inside the patterns. I get here the matches, and as long as this thing is not returning null, I can keep checking the next occurrence. And what I'll get in this is first the regular expression match will match the whole structure here, and then it will extract the internal match, which is this. And if I run it just to quickly show you, here's an extraction by regular expression, and here's the internal found match. And again, this is the second HTML element, and that's the found match. I'll share with you all those samples and demos about strings and about functions and about objects, and I think that you'll be very happy with this, more than you are right now.
Perfect.